Hello everyone, welcome back for another tutorial on a introductory statistics concept and an accompanying web app to help accomplish that purpose. In today's video, we're going to be talking about conditional probabilities, and one of my favorite examples for introducing this into the classroom. So this draws on the 2014 Ebola outbreak in West Africa. And in this example, we're going to be drawing on CDC data for the total number of cases in West Africa and the total number of cases that died in West Africa. And this web app allows you to visualize all of this information that we're going to talk about, and it really makes conditional probabilities what can be a moment where students kind of turn off their brain. It makes it approachable, and it highlights how intuitive this concept in the world of statistics is. So this web app starts off with a little introduction to the global impact of the 2014 Ebola outbreak in West Africa. And along the top, you see three tiles that give you information on the total number of cases, 28,616. These are either confirmed or probable, as the reporting guidelines would require. And then the total number of deaths that were attributed to the Ebola virus. So 11,310. And then if you just divide 11,310 by the total cases, 28,616, you get 39.5% as the mortality rate in all of West Africa. And so I introduced this using that information and this little table underneath it that splits out the rows by mortality, whether they died, which is a yes, or they didn't die, which is a no, and then the total. And way over here on the right, you see those same numbers that we were looking at above. Total number of cases, and then the 11,310 deaths. And what you have then is a tabular representation of that information. And so it's worth a conversation with your students talking about, the high fatality rate with this particular virus. And then introducing the idea that West Africa is actually made up of several countries. So what we're going to do is look at those totals over to the right, split out by three of these West African countries. So let's show the country breakdown here in a moment, but I just want to introduce you to the rest of this web app, what's down here. You have a chart that just shows you the total mortality rate as a percentage along this axis. And so you can see for what we have displayed in the table, we've got our 39.5%. Okay, so let's show the country breakdown. And what we have are those same numbers split out by Guinea, Liberia, and Sierra Leone. So within Guinea, we have the total number of cases, same for Liberia and Sierra Leone, and those total up to our 28,616 cases. Now, I usually like to ask students, just thinking about this and looking at this table, if I asked you to calculate the probability that an Ebola case died if they were in Guinea, and let them think about that for just a moment, I'll ask the class to respond to that. They will say, well, that should be 2,544 divided by 3,814, the total number of cases in Guinea. So they correctly, intuitively say the total number of fatalities in Guinea divided by the total number of cases in Guinea. And I say, that's great, that's perfect. What you just did there was calculate a conditional probability. If the subject is in Guinea, now what that if statement does is it says, well, we have information on these other locations like Liberia and Sierra Leone, and we have information on the total, but if I'm interested in Guinea, I'm going to ignore any of that information that is not from Guinea. it creates the new universe for which the probabilities we're going to explore come from. We are creating a condition and then identifying all of the subjects, objects, or whatever that meet that condition. So here we have a denominator now. Instead of 28,000, we limit our denominator to 3,814. I would ask them the same question. Well, what's the probability that a case of Ebola dies if they are in Liberia? And they'll do the same thing. They'll say, well, that's 4,810 divided by 10,678. And then, of course, the next one is just obvious at this point. What's the probability that an Ebola case dies if they're in Sierra Leone? And that becomes focusing on these 14,000 cases in Sierra Leone. There were almost 4,000 of them that died. And we can calculate those probabilities. And one of the really fascinating things about these probabilities now that I think the students really latch onto, and this leaves an impression about the conditional probability, is that the probability of mortality calculated that way, conditional on location, differs substantially between those countries. So, for instance, the probability that an Ebola case dies in Guinea is 66.7%, whereas it's 45% in Liberia and 28% in Sierra Leone. So I tell the students to imagine for a moment, pretend like we have a time machine and they are going to become an Ebola case and we're going to go back to 2014 in West Africa. Which of these three countries do you want to be an Ebola case in? It's kind of a strange idea, but the idea solidifies the fact that knowing this additional information about where the case happens gives you better information. Remember, if we just took West Africa altogether, the mortality rate was about 40%. But knowing that it's a case in Guinea, that percentage goes way up to 67% almost. Whereas it's 45% in Liberia and then 28% in Sierra Leone. So without fail, my students always vote to go to Sierra Leone in our time machine, not surprisingly. And we say, please don't let it be in Guinea, right? And I think this is really kind of helpful because it introduces the idea not only of conditional probabilities, but the idea of independence. Is mortality rate independent from location? Well, if all of those countries had about the same mortality rate and it was equal to the overall mortality rate, then it really wouldn't matter which country you were in, and yes, they would be independent. That's not the case here. Here, it totally depends on what country you're in, right? That means that there is an association between country, location of the Ebola case, and whether or not that case dies. So we kind of get 2 for 1 here. We usually haven't talked about independence at this stage, but we set an anchor point that we're able to come back to when we do talk about independence to say, remember that Ebola example? It was important to know which country we were going to because the mortality rates were so different between those countries. So those two variables were not independent of each other, right? So this is a fun example for a classroom setting. And with this web app, you can visualize all of those things. You can take them from this overall mortality rate to the surprise, fun investigation of the differences in the rates of those countries. This also spurs on conversations about public health and things about, I usually ask them, why would there be such different rates? And a lot of the responses have to do with things like, well, maybe certain countries spend more money on public health and infrastructure, and that all may be true. But we also talk about these large denominators up here in Sierra Leone and in Liberia, and a relatively small denominator in Guinea. And that leads us to a conversation about case definitions. Is the definition of what is an Ebola case the same across all of those countries? Well, I think that's something worth investigating, right? So if we're just considering anyone with a temperature during this time to be an Ebola case, then you may end up with a much larger denominator, making your mortality rate look a lot smaller. So this all leads into some very interesting public health questions. Later in here, and you'll notice that there haven't been any formulas really presented at all about a conditional probability. Those are coming here in just a moment, but the goal of this exercise is to really understand the intuition behind a conditional probability. That when I say, if the case is in Guinea, now I am focusing only on this Guinea column, and that gives me a total denominator now of 3,814, which is different than when we consider all of the cases of West Africa. Right, and then up here in the probability lab tab, we start getting into more of this idea of the notation. So let's calculate the probability of death given the region. And so we have the West Africa region where all of those countries are taken together. And we have that calculation here and a statement to go along with it. We can split that out into each of these countries so we can see the probability of mortality given Guinea or Liberia or Sierra Leone. And below that, we get sort of as a side note, a little bit of information about the relationship between the conditional probability and some of the more elementary combinations of events, like the intersection of those events. And so here's where they will start to see this formula. The probability of death given country is equal to the probability of the intersection of death and country divided by the probability of being in that country. So with these in hand, you could go back to that table and say, hey, let's identify the Ebola cases that make up this event. Let's say we're talking about the country here of Sierra Leone. So the probability of death and Sierra Leone, where is that in the table? And if you come back to this table, you can say, well, here are the cases that were in Sierra Leone and died. So the probability of that is the 3,956 divided by the 28,616. Right? So that's the probability of that intersection. We're considering all of the cases and just saying which ones are the ones that have these two characteristics, Sierra Leone and mortality, and then we'll calculate the probability out of all of our sample that they have those characteristics. Similarly, we can get that quantity and then we can say, let's divide that by the probability of being in Sierra Leone. And so we'll say, come back to this table, what's the probability that a case is in Sierra Leone? And students will correctly say, hey, well, that's 14,124 divided by all of the cases, 28,616. And so we'll say, yeah, that's absolutely right. And we'll write these out on the board so they can see the numbers, the intersection, this value over this value, divided by this value over this value. And then they'll see the cancellation that happens, reducing the conditional probability to simply the 3,956 over the 14,124. So hopefully this helps you set the stage in a way that they can go back and draw on their intuition when you are presenting conditional probabilities, and you can avoid starting off hitting them over the head with something like this, you can pick on something a little more intuitive, a little more interesting to sink their teeth into with that Ebola outbreak example, and then come back to these formulas to introduce them and show how their intuition is a integral part, is the fundamental part of these equations. And then the last part of this web app is a quiz mode, and it will ask you a variety of questions like what's the approximate mortality rate in Liberia, and then you go through that information from the table and enter it here, and you can check your answers. All right, I hope you guys enjoy this video. I hope this helps you approach conditional probabilities from an intuitive, interesting public health example.